suppose I should be checking my answers, especially right before a test. I hate making mistakes, but especially when it's right before a test, that's really bad. Okay, so looks good. Next one. Our function is y is equal to 3 to the power of x ln x. Okay, kind of intimidating here. Let's not try to be too intimidated. What is the overall rule here? What do we have going on here? Product, a quotient, composite function. Those are kind of the biggies where we have special rules that we have to consider overall. We'll log differentiation too, I guess. What's that? It is composite function, so we're going to have to use a chain rule. Good. So we have 3, not just 3 to the x, we have 3 to some function of x. So that makes it a composite function. So we have a derivative rule for 3 to the x. The derivative would be 3 to the x times what? If it was just 3 to the x. Let me write this out. What if it was just the derivative of 3 to the x, just so we kind of have a baseline here? I said it's 3 to the x times what? ln 3. So you can kind of think of it as being the derivative of e to the x. It's constant to a power of x. It's like e to the x, e is constant. What's the derivative of e to the x? E to the x. So it's kind of like it, but there's a little byproduct there, that ln 3 business. So the derivative of 3 to the x is 3 to the x times ln of the base. So just kind of remember that you need that when it's not a base e. Just kind of tack that on. All right, so we're going to try to use this rule here, but we got to also use a chain rule. So the derivative of the outer function is going to be that power thing, that exponential function. So the derivative of the outer function evaluated the inner function is going to look like 3 to the x times ln x times ln 3. And then we got to take the derivative of the inner function, which is x ln x. So I'm not done yet, but I wrote that d dx out front so you could kind of see the process here. That the 3 to the x ln x times overall the ln at 3, that was just the derivative of the outer function. Evaluate the inner function. So now we have to find the answer to the derivative of x times ln x. What's the overall rule? Product. You got 2 functions of x. Okay? Being multiplied. So we got to use the product rule. So I'll just kind of write that out here and then we'll put it together. So f g prime plus g f prime, or some variation of that, because it's multiplication and adding, we can write this in lots of different forms. But I'm going to let my first function x be my f, so f would be x, and then g prime would be the derivative of natural log of x, which is 1 over x, plus, and then we have g f prime. My g is ln x. My f prime is going to be 1. Oops, I forgot to write y prime in the beginning there. I was taking the derivative. So putting this together, we do not have to simplify, so we just have to make sure that we got the complete derivative worked out. If it doesn't look pretty, that's fine. Be careful here, I have to have parentheses around what I have here with the sum between. It's so tempting to do some simplifying here, which you can if you want, but you can just leave it too. Questions on that one?